Hello, my name is Edwin Ngare. This is my level 3 machine. What you are trying to achieve is trying to create a digital twin of the machine in VR. My role here was to implement the virtual reality to sync with the physical machine. Yeah.
Okay. My name is Brian Ruto, and we did the same project with the group members. And my purpose here was modeling of the various parts using Blender, and then later transferring it to Unity. Yeah.
Hello, my name is Alan Chalo. I'm currently undertaking Siemens Level 3 at Dedan, Kimathi University of Technology. Together with my group, I'm working on a project titled Integration of PLC 1500 Station and Virtual Reality Implementation. The project is mainly focused on combining industrial automation and virtual reality to create a more interactive and practical experience. Thank you.
In front of me, we are able to view the virtual machine, same as the physical. Then on my right, we have a simple user interface that gives us more information about the production and our simple control UI. So when I press the start, you'll see that a part spawns on the virtual machine. So for this to run, because it's a digital twin, we'll need to also physically place an object at the first sensor. For this, I will show you the magazine as it ejects part, that process flow. I will now press start 2 to spawn a part, and the moment part has been detected, it will be ejected, and the process continues. So for this one, I'll show you the part without a lid coming out from the magazine. So I will press start 2 to spawn a part. And as you see, on the physical station, it's a part without a lid. But on the virtual machine, it will also show a workpiece. This part, I will show the multiplayer side. As seen, I being the creator or the host of the room, I will log in by typing in my name and creating a room. Then after a while, I should be able to log in. Currently, I will enable my microphone so that any other person in the room can hear me speak. Moving around the room, as you can see, is the same model of the machine, only that many or multiple people can access it at the same time. So that is the room code. In the multiplayer side, that is what is used to identify that I've created an instance of a room. Then on my right side, I will have now the trainee. One of my members, Alan, will join, and we will see side by side, both of us seeing each other as we operate the station. So what you're seeing is a real-time video feed recording of both players seeing each other. From the trainer host side, we can see Alan, and from the trainee, who is the client side, we can see me, Edwin. So Alan will press the start button and as we can see, in both instances, the movement has been synchronized and the machine is running in both headsets independently at the same time. This is not the multiplayer. Whatever the machine does on one headset, it also does on the other headset, and both of them are in sync. So on the second sequence, as we've seen, he's pressed start 2, and start 2 does the small sequence as shown.
So, in our project, we decided to use Blender. Blender is a 3D modeling software used to create objects. And we chose Blender because it's flexible, it's easy, and supports animation and texturing. And also, in order for us to export this design to Unity, we have to change the file. And to change the file, you have to change the file into an FBX file that can be supported in Unity. Also, on another aspect, we have the aspect of meshes, which is it's a major concern in Unity. So we decided to use this mesh as compared to this. This is because a lot of meshes slows down animation in Unity. So this is why we chose this one, conveyor, as compared to this conveyor, so as to allow us to for smooth rendering and smooth movement in Unity. Yeah.
Hello, my name is Alan Chalo, and I will be taking you through a brief video presentation of the project that is the integration of PLC 1500 station and the virtual reality implementation. Before I begin, I want to give a special shout out to Real Virtual because it's the backbone of this entire project on the Unity side. It gave us the industrial simulation foundation that made it possible to build and connect the Festo VR and multiplayer system in a practical way. So in this video, I'm going to brush through on the main scripts used in our project, explain what some of the scripts are responsible for, and briefly show the tier portal program. So on the Unity side, uh, the project is built around several groups of scripts. We have scripts for interaction, for gripping, conveyor motion, cylinder motion, suction. We also have sensors, the UI logic, and also for PLC communication. So I will be starting with the gripper scripts. If you Okay, the main purpose of the gripper script is to control how the gripper interacts with parts of the simulation. In this case, our game object, which is a cylinder with lid or without lid. And in the script is responsible for detecting the object, grabbing it, keeping it attached while the gripper is active, and then releasing it when needed. So it acts The gripper script acts like logic that says what can be picked, when it should be picked, where it should be held, and when it should be released. So the gripper script helps to create some sort of behavior for controlling attachment and releasing in a predictable way. So next will be the script that controls the conveyors. Okay, so this one is the most important script because the conveyor is what moves the parts through the station, and the script does not work alone. It works together with motion tools provided through the drive script, and also the transport surface. The working principle is actually straightforward. The drive gives motion to the conveyor mechanism. The transport surface makes sure the object on top of the conveyor is carried along within that movement, and also the conveyor control script decides when the conveyor should start, stop, or change states. Yeah, so instead of manually moving every object by code, the project uses a cleaner and industrial simulation approach. So the conveyor itself is driven as a machine element, and parts that ride on top of it through transport surface logic. So another important part is the drive cylinder script. So this is mostly used to move objects such as this gantry arm, and well, cylinders are essential because they represent real industrial actuators. They move parts, position mechanisms, or even trigger operations in sequences. So the working principle in this case, just a minute. So the working principle is when a condition is true, the cylinder extends for this particular arm, for the y-axis, yeah. So it extends. When the opposite is true, it retracts, similar to the movement in the x-axis in this case. So the next important script is the fixer script, and in this project it's used to simulate the suction behavior, if I may. Yes. Okay, so this is very important because suction in simulation is not real vacuum. The idea is when an object is picked by the suction tool, it may stay locked to the tool through the vacuum holding it. That is where the fixer scripts come in. Its role is to stabilize or fix the picked object so that it behaves as if attached to a suction point. And I think it will be very evident in the video that plays through all the functions of this simulation. Next will be the sensor scripts that we used in various points, also provided by Real Virtual. Some were used for tagging objects, detecting whether the game object has a lead or not. Also, others were used to know whether a part is present, lead is present, object is in correct position, and whether a condition should trigger the next action. And this is important because industrial automation depends heavily on sensing. The machine does not move blindly, it waits for confirmation. And so the scripts are what allow Unity to simulate the logic. They connect the physical looking scene to the actual decision making. So now I want to move to the most important part, that is the communication. Yes, the connection between Unity and the physical PLC that operates the Festo machine. So this is where the simulation stops being just a visual model and starts behaving like a real automation system. So the connection is mainly handled by these two scripts, the S7 connector module and the PLC tag writer. Starting with the S7 connector module, it's mainly used for reading data from the PLC into Unity, and it connects the Siemens controller using settings such as the IP address, the CPU type, rack, slot. Yeah. So once connected, it monitors the PLC tags continuously. This means that if the PLC changes a memory value in this case, Unity can detect that change and update the simulation accordingly. So next will be the PLC tag writer, which is shown. Okay, so this is quite the opposite of the S7 connector module. So when a user interacts with the Unity interface, for example, by pressing say start 1, start 2, those commands are sent to the PLC through the PLC tag writer, and we'll see in short where these affect in the tier program that controls the PLC logic. So the working principle here is the user presses maybe a button in Unity. Unity changes the corresponding tag value, then the PLC tag writer sends the value to the PLC receives the command and executes the program. So this is a direct write operation. And yeah, so if the S7 module is the script that reads the PLC, then the PLC tag writer is the script that writes the PLC. So there's a very big distinction between the two, and one such that one reads the machine state into Unity and the other sends commands into Unity. So we'll move on to the adjacent tier program as shown. Okay, just a minute. Okay, now let me briefly explain how this works. So in the PLC program, the main block is as shown, and this means it runs continuously in a scan loop, and the main block calls several functions. As you can see, we have separated the project into various functions. We have the control panel, the conveyor panel, conveyor station, one that operates the gantry, and a sequence 2. Yes, so the logic is modular. Instead of putting everything in one large block, the station behavior is broken into sections. I think, okay, this is a good practice because it makes the code easier to read, test, and maintain, as shown in these various sections. So we have used the step method to control various functions in a particular function block as shown. So I think this is straightforward on its own, and from what is shown here, the start and stop buttons are used to enable and disable different sections, and they are the ones that control all the whole process, as we've seen in Unity. Yeah, so the control begins from the start and stop buttons in both cases. Yeah, so I hope that best describes what our project entails, and yes, we've achieved what we intended to achieve, and thank you for listening.